Problem number 5. Y prime is referring to specifically dy dx. And to separate my variables, I'm going to first multiply the dx over to the right side. And now I already have anything with y with dy, anything with x is multiplied by dx. I'm ready for integration. With respect to y, the integral of 1 is y. Now for tangent, if you forget, you can come up with it. So I'm going to do that to the side. Integral of tangent y dy. Tangent is sine divided by cosine. If I do a u substitution of the denominator, the derivative is negative, the numerator, but constant multiples aren't an issue. I'm going to multiply the dy over to positive sine y and multiply the negative over to the du. And so what I'm going to do is I'm going to replace the denominator with a u, and I'm going to replace sine y times dy with negative du. And now this is equal to the integral of 1 over u times negative du. I'm ready to integrate. Negative natural log of absolute u plus c. Put the u back in. And there's the formula. An alternate formula you may run into uses a log rule to make a multiplication by -1 turn into an exponent. Be careful, this -1 is an exponent. It is not a symbol for inverse. You cannot write it in the position that you would write a +2 exponent in a trig function. This is asking for the reciprocal of cosine, and that is secant. And you have those two options. Now, coming back over to the problem, I'm going to go ahead and use the cosine version. So that means I have y and then minus natural log absolute cosine y. I'll leave the plus c for the other side. On the right, I integrate, I get x cubed over 3 plus the integral of 1 with respect to x gives me x plus an unknown constant. You are not going to be able to isolate that y. This would be considered solved right here. And that is plenty far enough to go. Let's take a look at number 14. In order to solve 14, you're going to have to separate the p and the t. And fortunately, there is a property for distribution of exponent root over multiplication division operation. I am allowed to distribute my square root over the multiplication of p and t. And now I can see them separated. I'm going to divide root p over to the dp side, and I'm going to multiply dt over to the right. As you prep for integration, be very careful. Don't universally logarithmatize. You have You do not have in the denominator p to the 1 power. If that was the case, it would be a logarithm. But anything else means power rule. You have p to the negative 1/2. And then I changed the positive square root of t to t to the positive 1/2. And now time to integrate. Add 1 to the exponent, negative 1/2. Adding 1 gives me positive 1/2. If I divide by a half, I would rather multiply by 2. On the other side, add 1 to the exponent. 1/2 plus 1 gives me 3/2. And instead of dividing by 3/2, I will multiply by its reciprocal and plus c. I can isolate my p. I'm going to first divide 2. And that's going to give me 1/3 t to the 3/2 plus some constant divided by 2, which could morph into just another general constant. Now a 1/2 exponent is the same thing as saying square root. So to finish isolating p, I'm going to square both sides of the equation. This would be a correct answer. Most math people are going to take an unknown constant divided by 2 and just use a different letter for that unknown constant. I'll use a capital D. And this was an initial value problem. That means I need to take this and find my D. I have the point 1, 2. When P is equal to 2, T is equal to 1. And then I need to square root both sides. I'm actually going to get a plus or minus square root that I need to contend with. And that means that D is equal to either positive root 2 or negative root 2, but not both, minus 1/3. I've got to figure out which one it is. So what I'm going to do is I'm going to temporarily replace my D with the entire expression. That means I have the following. Now, to figure out which of those it is, plus or minus, and it is only one of those. This is one specific constant. Use the point that is known, the point 1, 2. Plug it in and see which of those two, plus or minus, creates a true statement. If P is 2 and T is equal to 1, I have 1/3 minus 1/3, leaving me with either a plus or a minus root 2 squared. Well, that makes both of them true. This does not actually give me information about whether I'm dealing with the positive or the negative. That means I need to go somewhere else. I need to back it up, and I want to go to this place before I did the squaring. And I am going to remember that my c divided by 2 is the d, which is the plus or minus root 2 minus 1/3 that I'm trying to figure out which one it is. First thing I'm going to do is put that unknown constant in. So I'm going to right now still have the p 1/3 t to the 3/2 plus, and then the plus or minus, I'll write plus or minus right here, root 2, and definitely the minus 1/3. I'm going to highlight this is what's under question. This is the point that's going to determine what makes a true statement. The p-value is 2, so I plug that in. The t-value is 1, I plug that in. I get the 1/3 minus 1/3 that I saw before, but this time I can see this will only be true if I use the positive square root. Positive wins, negative loses. And that's why that is the particular answer. So I'm going to come back over here and rewrite this with just plus. So I don't have to rewrite the entire equation again, and there you go. Yay!